Hi, Assalamualaikum. Okay, in this video, we will be talking about LU decomposition problem. My friend and I will be solving the problem using hand calculation and using Mathematica. Okay, let's look at the question. It told us to solve the following system of linear equation using LU decomposition by using hand calculation and using programming software, which is Mathematica. Okay, these are the linear equation. There are three of them. This first one, the second one, and the third one. Okay, first we will be using hand calculation to solve the problem. However, before we start solving the problem, we need to check whether the matrix A has LU or not. Okay, there's theorem said that LU, let A be a non-singular n by n matrix, then A has an LU decomposition if and only if all the principal minor absolute AR when R equal to 1, 2 until n are non-zero. So, looking at our problem, our matrix A will be 3 by 3, which is A equal to 8, negative 5, negative 9, negative 1, negative 1, negative 10, 4, negative 1, and 2. So, there will be 3 principal minor because this is 3 by 3, n by n, r until n. So, for the first principal minor, we will get A1 equal to 8, and this is not equal to 0. So, we can continue for the second one, which is absolute A2, principal minor A2. We will have 8, negative 5, negative 1, negative 1. And to calculate the value, we will be using this formula. We just put all the information here into this formula and we will get that equal to 8 times negative 1 minus negative 1 times negative 5, and the answer will be negative 13. And negative 13 is not equal to 0, so this is a non-zero. So we can continue for the third one. Our third principal minor will be equal to 3 by 3. We just took all the value from our matrix A, 3 by 3. Then we will be using another formula because this is a 3 by 3, and for the second one, this one it's 2 by 2. So we need to use another formula, which is A equal to A, B, C, D, E, F, G, H equal to this one. So we just put all the information here into this formula and calculate our principal minor value, and we just put it in here and it will be like this. And our third principal minor will be 8 times negative 12 plus 5 times 38 minus 9 times 5 will be equal to 49, and 49 is not equal to 0, so it is a non-zero. So we can conclude that since all the principal minor are non-zero, then A has LU decomposition. Therefore, we can solve this problem using LU decomposition. Okay, let's start the second step, which is factoring. This is our given linear equation, and we will need to change this format into this one, which is AX equal to B. So this is our matrix A. This time our matrix X equal to matrix B, which is B, we took it from here, 1, 2, negative 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatimah Amira, and I will continue the presentation from here. From the system of linear equation AX equal to B, we can construct lower triangular matrix L and upper triangular matrix U. So to do that, we perform elementary row operation such that 2, 1 element is equal to 0. Our 2, 1 element is negative 1. To zero the 2, 1 element, we will perform this operation, which is row number 2 plus 1 over 8 row number 1. So this gives the multiplier of 2, 1 equal to negative 1 over 8. We then continue to perform row operation to eliminate x1 from the third row. Our x1 is equal to 4, as you can see. This gives the multiplier of the third row and the first column is equal to 1 over 2. Same goes for the second column. We perform row elimination to eliminate x2, which is 3 over 2 from the third row. This gives the multiplier for the third row and the second column is equal to negative 12 over 13. Once all the multiplier for the 3 by 3 matrix are obtained, we will have our upper triangular matrix here. While for the lower triangular matrix, we will define it in this form. So we have the multiplier for the second row and the first column right here. Same goes to the other two multipliers. Next, by forward substitution, we can solve for the values of y. As we can see from the equation 1, y1 is equal to 1. And from equation 2 right here, we will have negative 1 over 8 y1 plus 1 times y2, which is y2, is equal to 2. Since we know y1 is equal to 1, we can solve equation 2 by substituting the value of y1 equal to 1 into the equation. Now, solve for the equation, we will have y2 is equal to 17 over 8.
Okay, Assalamualaikum. My name is Wano Akila binti Wanubahan and I will continue on forward substitution. So just now we already have the value of y1 and y2. So now we will find y3. Okay, we will just substitute the value of y1 and y2 in this equation and we will get our y3. That is negative 7 over 13. So we show our full value here. y1 is equal to 1, y2 is equal to 17 over 8, and y3 is equal to negative 7 over 13. Okay, for step 4, we need to do back substitution to find the value of x1, x2, and x3 by using upper triangular matrix. Okay, then since it is much easier to find our x3, so we will do our x3 first. That is negative 49 over 13 times with x3 is equal to negative 7 over 13. So our x3, when we simplify it, we will get 1 over 7. Okay, so we will continue for our x2 and we will do the same thing to x2 by substituting the value of x3 that we got just now. So the value of our x2 is equal to negative 16 over 7. Lastly, we will substitute the value of x2 and x3 in this equation to get our x1. So our x1, finally we will get negative 8 over 7. Lastly, we'll show our value here for our x1 that is equal to negative 8 over 7 and our x2 is equal to negative 16 over 7 and our x3 is equal to 1 over 7.
Hi everyone, now I will show you how to solve the following system of linear equations using linear decomposition by using Mathematica programming software. So the first of all is we need to open the Mathematica applications. Select new document. Okay, the first of all is we need to insert our matrix A. So we call matrix form. So we get the output in the matrix form. A is equals to, the first row is 8, negative 5, negative 9. Second row is negative 1, and negative 10. Oops. Negative 10. Then the third row is 4, -1, and 2. Okay. Then we press Shift and Enter to get the output. So this is our matrix A. Then the second step is we need to compute LU decomposition of a matrix A. So LU, P, and C is equals to LU decomposition of matrix A. We will get 3 elements, which is the first element is LU. LU is the matrix consisting of upper and lower triangular matrix, and the second element is P, which is the vector specifying row used for pivoting, and the third element is the condition number of the matrix A. So we call back our matrix LU, so we can get a better vision. So the next step is we need to call our upper triangular matrix and the lower triangular matrix from the LU. So matrix form, we call capital U for the upper triangularized of LU. Okay, so we get our upper triangular matrix. Then we call our lower triangular matrix, which is the capital of L. We call lower triangularized of LU, comma, -1. Why -1? Because we need to call the number of the below diagonals only, which is -4, -8, and 13/5. Okay, plus with the identity matrix of 3, which is mean 3 by 3 matrix, and the diagonal is equals to 1. So we get our matrix L. Then the next step is we need to insert our vector B, okay, which is equals to, the first row is 1, the second row is 2, the third row is -2. Okay, so this is our vector B from the equations. Okay, then the next step is we need to find y that solve the matrix equations Ly equals to BP. So matrix form y, so we use linear solve. Okay, the lower triangular matrix and the vector B and elements B. So we get y1 is equals to 2, y2 is equals to 6, and y3 is equals to 7/5. Then the last step is we need to find x that solve the matrix equations ux equals to y. So the same steps, matrix form x is equals to linear solve the upper triangular matrix capital U and the y. Shift and enter. This is our solutions, which is x1 is equals to -8/7, x2 equals to 16/7, and x3 is equals to 1/7. I hope you guys can understand. Thank you.